So today we will continue for lecture 10. And last year this topic was very popular because there are a lot of zk-Rollup and released to the market, went to mainnet. But this year still popular. It's only 1 year frame. So today we'll cover the topic about Optimistic Rollup and zk-Rollup. But before we kick off the rollup session, I know many of you are here, which is good. Those haven't coming, I may count the attendance very soon. And I has been always student all my career. So there are a few type of students in the class. At a certain time, I belong to some type of the students. The first type is not here at all. And the second type is you are here, which is good, listen to the class, and trying to catch up with whatever the teacher is talking about. The third type is the ones always come up and asking questions. So far in this batch, I don't think any of you raise a hand asking any question yet. I hope we can improve. It's really important for me to understand you, what's your questions, and also for you to understand a little bit deeper. Maybe you can also help your classmates to understand a little bit deeper some of the topics. Because the best type of the students actually is not only asking the questions, they are actually thinking about any startup ideas when they listen to the class. And I post this, the last session, the video to YouTube and another channel. There are people actually really go through that and asking questions like this, right? If you look at this chart, it's just Lightning Network, conditional transfer. When the channel is set up, you have to, all the participant has to deposit BTC, right? But the blockchain is here to make the transaction or money more efficient. I was talking to the head of digital assets from Standard Chartered Bank. The guy was asking me like, Neil, you know why I'm looking into crypto, even though the industry is very early and it's not mature that much yet. And also, as a bank, it's difficult to hire the people who can really understand the crypto and going deeper into that. But he, as the head of the digital assets, still looking into a lot on whatever topics coming up. You make a guess why. Why, as a bank, they are a pretty large one from Europe, I think, and they even predict the BTC, the valuation will be much, much, much higher than the current price. But other than trying to analyze the market, what else do you think the reason and the needs as a head of digital assets are looking into crypto? Any idea? You guys are not listening. I hope you really listen, asking questions. Try to answer it too. So actually, the reason he told me was when you look at the current banking systems, when the money started to flow, there are a lot of places you can improve the efficiency of monetary system. One of the example he gives to me is for SWIFT. Whenever it's in weekend, the money is stopped, which means no matter it's like $10 US or millions of or billions of US dollars they want to transfer to another place, the money just hang there. And to him, or to many banking industry players, this is not efficient at all. And he has been searching for, and not only him, many companies has been looking for the efficiency of the monetary systems. And they find crypto is one of them, right? There are definitely more other solutions, but crypto is one systems can make the money flow. And that's very important. You think about, I was told by another bank called Greenlink Bank from Singapore. He is the head of Web3, actually. Surprisingly, they also have this department. When he told me why he looked into Web3, it's really because the Greenlink is the bank set up a joint venture by, I think, two companies from China, but they set up in Singapore, get a license here. And one of the companies being part of the joint venture is they were doing like kind of money transaction systems in China, where, for example, whenever BYD, this electric car system, a car company, deposits, for example, 10 million US dollars into a bank account, the money is actually, the money will flow. But in order to make it more efficient, they actually generate a ledger on, well, in China it's like a private crypto blockchain systems, but still they generate ledger on the private blockchain. The thing, once that deposit started, they can actually use that ledger to make a payment to their suppliers, so that they can use that to pay and ordering some of the parts to the car companies. And the downstream companies can use their own similar way to deposit and start to use that ledger to make a reservation from BYD as a car company. So by doing that, the money is in the bank generating the interest, but at the same time the money can flow. And that system is 24/7. Similarly to, there's a student was asking me, not you guys, I hope you guys can ask questions. They're asking, things you guys are depositing all this BTC in the ledger, the money just stuck there. How can we make it more efficient and make it flow? Because by right, crypto can do that, right? Why, as a Lightning Network, you don't do that? So the idea was, actually, why can't I stake this BTC somewhere? And the staked assets can be regenerated again on another asset management system or liquidity pool, so that the BTC can be generating interest and profits. Even further, if that system can flow further, that profit-generating smart contract or script, in this case, which you can use Taproots, for example, to generating kind of DeFi system to generating profits, interest for whatever stake, the assets you stake onto those hubs. So that's actually this idea has been started about a year ago. There are companies raised a big fund for this idea. I think the company has been in the middle of implementing that. But what I'm trying to see here is, in the class, don't just listen. Ask questions and also think about anything else you can do. And that was a really good question. Actually, even that idea was not mature. If you can figure out a better idea than the company I mentioned, who knows, you can respond. Because whatever I'm trying to discuss with you here what's actually happening in the industry. Okay, so just review a little bit for the generic commit chain workflow. So for commit chain, it's a layer 2. where all these blocks will be generated on the layer 2, and periodically the commit, the state root, headers, and also transaction data, which is core data, back to layer 1, so that the smart contract, which is commit chain smart contract here, can do corresponding validations based on different proof generation and validation method. So this is the very standard workflow. The first topic we're going to discuss today is the Optimistic Rollup. To making sure the state is validated on layer 2 and also layer 1. We have this fraud proof, which is fisherman proof, to allow execution and transactions execute on layer 2 optimistically, which means whatever transaction happening on layer 2, by default, the blockchain will deem all those transactions as a valid transaction first, as an assumption. That's why it's called optimistic. But whenever there's a period of time, any validators trying to submit a fraud proof, the validators will make sure whatever the fraud proof raised by the validators or other parties is executed, so that they make sure the state is valid for the new generated block on layer 2. So that's the first key idea for Optimistic Rollup. And the second key idea is, so for Optimistic Rollup, at least from the beginning till at least last year, we are not the one deal with data availability. It's really troublesome. Today, if we have time, I think I need to catch up more. Maybe we'll start to cover data availability later on today. It's really complex. And even for the data availability itself, carries a lot of startups valuated like billions of dollars, trillions of dollars for different ideas to make sure the data is available and scalable. But for Optimistic Rollup, in this case, this is not their priority. We really rely on the Ethereum to make sure the data is available. That's the two key ideas for Optimistic Rollup. And this is the step. So when there's a new transaction happening, whoever initiated the transaction signed the transactions, and the old state, for example, someone here transferred money to here, the old state is like that. This is the previous balance. So then they have to apply the transaction and calculate the new state root. With that transaction happening, the layer 2 will generate the new Merkle root state and also the Merkle tree, right? So once this is done, we will insert this transaction with the Merkle tree to the new Rollup block. But at least, absolutely, this new block can consist thousands of these kind of transactions in one block. And once the block is generated here, they will commit. For Optimistic Rollup, they will commit the transactions, signatures of the transactions, the Merkle tree, and also the headers onto layer 1. They send a lot of transactions to layer 1 for Optimistic Rollup. So that's the flow of Optimistic Rollup, and also what happened when the transaction happened, how the state is transit from the old one to the new one. So the ORU is Optimistic Rollup. So some of the Optimistic Rollups choose to upload all the transactions to Rollup contract first, while waiting for validators to commit new state root. So actually, what here is trying to say is, they don't calculate the new state root first, and they upload all the transactions to the layer one to make sure the state can be handled asynchronously, because you can do that because all the state will have a validation period time where the fraud proof can be submitted, and when they commit, they don't need to guarantee the state root is calculated at that time. So that's why it's fun. This question maybe appears like without the validation proof, how does the Rollup contract here know whether the new state root is correct or not, right? For example, by right, Bob sent, for example, 10 ETH to Alice, but Bob doesn't have 10 ETH. Then how can he make such a transaction and fool the systems? If that's happening, then there's a need a way to make sure this kind of transaction won't happen. So that's why there's a dispute. There's a dispute period time to handle such edge case. I think the maybe better example is Bob trying to withdraw 10 ETH, but he doesn't have 10 ETH. If layer one actually accept this transaction, Bob will actually getting 10 ETH from nowhere, which is definitely not what Ethereum want to see, right? So that's why there's a dispute. So how the dispute happening is the third-party validators. Remember, the third-party validators is not their internal validators for the layer 2 or layer 1. The third-party validators will submit, we'll call this contract function called verify state transaction, passing in the state of the previous block and the block itself for the current block, and also a witness or Merkle proof to help this function to verify the new state here is actually valid or not. Well, basically, whenever this validator trying to submit a challenge, it means there's some issue. This validator want the system know or blockchain know there's an invalid transaction. And when the smart contract of the Rollup at layer 1 receive this kind of challenge, the smart contract will start to verify the challenge. And if the challenge is successful, for example, this validator detect Bob doesn't have 10 ETH, but he trying to withdraw 10 ETH, and the new Merkle tree is generated. Then this challenge is successful. So whenever the challenge is successful, to incentivize the validator to do more challenge, that's where the validator will get a reward. For example, certain amount of ETH to the validators. And if the validator is actually submit a wrong challenge, the smart contract will slash the validator. So by doing this, right, at least you have a way to incentivize and punish the third-party validators. But you know what's happening in reality? Do you know what's happening in reality? 2 years ago, I was trying to study into some of the Optimistic Rollup. I don't want to point whom. And because it's all open source, I want to see where this function go. And I end up find out there's no such function being called or implemented for those rollups. And then I started to do more research and find out, at least at that time, for those Optimistic Rollup I was studying, they do not have a third-party validator at all. So basically, Yu Yang will come next week. You can ask her how, I will leave a question mark to you guys, and you can find out how they do the validation in this case for base. But finally, about remember the rollup I was studying, they carry about 2 years ago. I think the TVL was about $1 billion US, I think, if I remember correctly. And if some hackers can hack the systems, they are actually able to doing malicious attack to the rollup systems. But why they didn't do that is really because the I'll tell you as your OSR can continue. So basically, for any transaction more than certain amount, they do manual approval. If not more than certain amount, by default, they think it will be fine. Because they do their own calculation for the economy, if the hacker decide to hack the systems, is the cost to hack the Optimistic Rollup will be much higher than the threshold they set for the manual check on the withdrawal amount. So that's how the system was working. But finally, about a year ago, I heard some of the Optimistic Rollup trying to implement that. I think now they should have one in place finally. You can look into the TVL, how much the TVL, all the layer 2s have right now. I think they have to do it. So anyway, the dispute resolution can be one round, where the challenger will just submit a challenge, or multiple round, where after he submits one dispute, he can submit another one, multiple round, until the validators are the smart contract is able to verify whether there's really a dispute or not. Arbitrum doing a little bit differently. They are using like multiple round rollup to make the verification more efficient. As for how they do that, it's actually an interesting invention from them. You can read more about their white paper. In general, the Optimistic Rollup, the good part is like they have this state validity ensured by fraud proof. Finally, right? Or else they have to use the manual check. The other advantage for the rollups is they don't need to they don't actually handle the data availability. They pass on to Ethereum so that the system can be more simple, right? Actually, the third one to me is more important as their advantage, which is whatever. Remember, last session we talked about some of the limitations for other previous layer 2s, right? You can't deploy a smart contract running any logic on layer 2 for the previous layer 2 solutions, but for Optimistic Rollup, they are the first working production environment. Any developer can deploy any EVM compatible smart contract onto layer 2. That's a big win because for developers, they don't want to rebuild another smart contract for another language. They still prefer Solidity because that's what they did for Ethereum. And now you are a layer 2 for Ethereum by right. You should have the same programming language, right? Like it's the same thing when I talk to you about PinCap, they scale MySQL, but whatever the developer used to work when they interconnecting with MySQL, and now when they ever transit to PinCap or TIDB, the whole interface is now changed. It's fully compatible, so that the developer do not need to do anything, and they can move their application smoothly to the new systems. To developer, this is actually one of the big factors when they decide whether they want to use your blockchain to deploy the applications on top. And but in reality, as I mentioned, even though by right the Optimistic Rollup should leave about 2 weeks time for the fraud proof, because it takes time for all the third-party validators to submit the fraud proof and make sure before they submit a fraud proof, it's a valid fraud proof. It takes time. That's why they have to leave a long time for the third party to do their due diligence. But in reality, the finality, which means the layer 1 will accept the transaction happening on layer 2, only need a 1 block confirmation. So they have to kind of give up this to the 1 block confirmation due to the user. Whenever, imagine I'm a user, I come to Optimism, for example, another OP layer 2, and the user want to restore their deposited ETH from the layer 2 back to their layer 1 wallet, and they want to use it on layer 1 or for other purpose, or withdraw to centralized exchange, exchange to USDT, or exchange to fiat. You tell, as an Optimism protocol, tell the user, sorry, this is your instruction, but you need to wait for 2 weeks before you are able to withdraw. That's a terrible experience, right? So think about like I'm going to the bank, and the banker tells you, Neil, you're okay, you have all the balance in your account, but in order to withdraw, you have to wait for 2 weeks. We will message you, and you'll come over and withdraw again. So that's why in reality, Optimistic Rollup gave up this challenge period. Some of them using manual validation, some of them using so-called watchtower validating. But then, as I mentioned, there are a long time period of time, there's no validation at all. But whatever this watchtower validating is, basically a validator trying to sample and validate the transactions randomly to make sure all the transactions are valid. By right, they should do that, but some certain time, they even doesn't do that. But at least from user experience perspective, it's just need with 1 block confirmation, which is about 10 minutes on layer 1, to withdraw the fund from layer 2. And the costs are pretty low. It's about, for now, after all the optimization, the costs on layer 2, Optimistic Rollups, are about 20 plus times cheaper compared to the cost on the layer 1. And for dispute, the dispute in general, it should be cheap, but actually, the reality, well, think about if everyone is behaving on layer 2, right? And the third-party validators are trying to making the dispute, and they want to get rewarded whenever they find a issue on the transactions, but somehow everyone is behaving on that blockchain, and there's no issue at all. then economically, it won't be worthwhile for them to do that, right? Because after running for a year, I didn't get anything, but I have to turn on my machine and keep running the dispute checking, which which is not really good for this kind of validators. So I also already mentioned some of the issues for Optimistic Rollup where the safety requires always online assumption, and you have to rely on the third party to challenge. But in reality, it's not really worthwhile, or the ROI, return on the investment, is not worthwhile for the challengers to always turn on the systems. And the withdrawal take 1 to 2 weeks, depend on how we are implementing that, which is a long time, but then they sacrifice that with this one block confirmation. But in reality, by design of the systems, they should leave at least 1 week time for withdrawal to happen. So that's the Optimistic Rollup. So the second type of the rollup is called zk-Rollup. They are not only coming here to rescue Plasma, but also trying to rescue Optimistic Rollup due to all the issues we just mentioned. The key idea is as a layer 2, I can use all the zk proof methodologies to provide a validation proof of the new state root, so that the verifier on the layer 1 for the smart contract can verify whether the proof is valid or not. And so for some of the zk-Rollup, they use layer 1 for data availability, but for some other rollups, we will later on talk about it, they actually use third party for data availability. There are different terms for this kind of rollups. I will cover a little bit more. But these two are the key ideas for the zk-Rollup. So because of that, the flow for zk-Rollup is a bit different to the Optimistic Rollup. So we take a transfer transaction, for example. Same thing happened for the transaction here. And when same thing, you generate a new state root with the updated transactions. And same thing again, you commit a new rollup block here at the layer 2. The step 4 is different, where the zk-Rollup actually generating validity proof from the layer 2 by using either zk-Snark or zk-Stark. We'll talk about the difference later on. Then you commit that proof to the layer 1 smart contract. And once the layer 1, for example, you generate a proof called pi. So once the layer 1 smart contract of the rollup smart contract receive that proof, immediately the smart contract will run a verification due to how the proof is designed for the zk-Rollups and the zk proof. The smart contract on layer 1 for the rollup actually can immediately verify whether the new state is valid or not. So that's actually the beauty of the zero-knowledge proof. I'm not sure how much further did you guys study after Prof. Guo talk about zk proof. But here is a very good example why the mathematicians really taking so long to study the zk proof, and finally they find a good use case for the zero-knowledge proof generation and verification. Actually, we'll dive deeper into it today on how give you guys a kind of idea how that system was designed and implemented into a real zk-Rollup. Hopefully that help you understand further about the zk-Rollups or zk proofs. Similarly for deposit, as I mentioned earlier, for any layer 2, in order for the layer 2 to have assets, they deposit through the layer 1. You deposit like 10 ETH to the layer 1 Rollup contract, and you append the transaction to the inbox, which means the smart contract understands you are trying to deposit the 10 ETH to the wallet on the layer 2, mapping from the layer 1 wallet, your layer 1 wallet address. And so once they receive that, basically these users' wallets on layer 2 will receive a deposit correspondingly. So because of that deposit action or transaction, there's a new state happening, right? The change, for example, if this is the Bob's layer 2 wallet address, and this transaction will change, the state will change, correspondingly the state root will be changing. So no difference to the fourth step. The new block will be generated on the Rollup, and similarly, the same flow, the proof will be generated from layer 2, and the proof will be committed to layer 1. The layer 1 smart contract will verify the proof. So basically that's what's happening for a deposit. Similarly to a withdrawal, so the withdrawal, let me ask you a question. How many of you has ever deposited and withdraw from a layer 2? Okay, great. So that, when I talk about this, you guys know what I'm talking about. If not, you guys trying to, find any Rollups and trying to do a deposit and to withdraw. So if you withdraw from the Rollup contract, basically you have to provide the Merkle proof of the balance in the state tree, right? And whenever the Merkle proof received on the layer 1, so basically you append the withdrawal transaction on so-called inbox, or actually it's in the Rollup smart contract, and the proof will be deducted correspondingly from the address. So this deposit is pretty straightforward. You don't need to go through. You still have to go through this whole flow to withdraw, but whenever you withdraw, right, the done this validation, proof generation and withdraw and verification before you are able to withdraw. By right, all this proof should happen, can happen in 10 minutes, which means anytime the smart contract on layer 1 verify the withdrawal is valid, basically verify the proof generated on layer 2 is successful, the user is actually able to withdraw immediately after 10 minutes. That's the time frame in theory it should work, but in reality, it's actually more than that. I'll give you one example. I was using Stockware before Starknet. When you withdraw, actually it's about 8 hours, which means you init a withdrawal action on their bridge, and you have to wait for 10 hours actually in order to get the withdrawal happening to your layer 1 wallet address. Do you know why? why in reality they decided to actually extend to 8 hours. They actually can do it in 10 minutes. Any idea? Or else I can give you guys a showcase on what I mean on a withdrawal. Let me show you guys here. This is actually in production. Let me see whether I can switch to Safari. So for Starnet, it's a little bit different because they are not EVM compatible. Later on, I'm gonna explain you why. They actually have to connect the wallet twice because you have to connect wallet on layer 2 and connect wallet on layer 1. But once you connect it, you authorize the executions on the UI. And in this case, I have to update and switch the network to Safari. Okay, I don't know where to switch the network, but maybe I can do it on the mainnet, just to showcase you guys how this works. For example, if I want to withdraw this USDC, if I withdraw one US, I have to, because I just now was trying to switch the network, so that's why I have to reconnect again for the wallet. And now you can see I have some of the deposit on layer 2. And if I withdraw 10 stock token from layer 2 back to my layer 1 wallet address, so here is what's happening. And I'm not sure whether you saw that just now. It's coming through very quickly. But as you can see, right, just now I just initiated a withdrawal transaction, and the Starnet as a layer 2, zkRollup layer 2, the withdrawal was initiated on Starnet, and in order for the layer 1 to receive the withdrawal amount, you have to wait for 12 hours. Now they extend to 12 hours for the transaction to be happening. That's really long, right? Even worse than the Optimistic Rollup. So my question was like, why they can do 10 minutes, but why they extend to 12 hours? Any idea? No? So basically, what I mean here, you see, this token is still in process. I can't use it at all until this step, the verification is done. The issue for the zk-Rollup is, even till now, the proof generation is pretty expensive. For now, the Stockware is using, later on I actually have a case study for Stockware. This just now, the demo actually will help you understand a little bit more. for the systems. The proof is still very expensive, and somehow there are not so many transactions happening on layer 2. If you only have, for example, 100 transactions in 10 minutes, I have to generate a new proof based on these 100 transactions. And when I did a withdrawal, right, you saw that I actually pay the gas as a Stark token to StarkNet. And that is actually paying the proof and all the costs for the user to withdraw from layer 2. If you only have 100 transactions in 10 minutes, and for example, proof generation is about $5 US. Now actually per proof, the cost is about $5 US. So each 100 transactions, for 100 transactions, each transaction, the cost is about 0.05 US. But just now what I paid is about 0.0002 US. So, which means the 100 transaction, the cost paid by the users for the gas is not enough even just cover their proof generation cost, not mentioning their manpower cost, operation cost, and all that. So that's why in reality, the Rollup actually take about 12 hours, some of them 8 hours, to actually generate the proof and give the final withdrawal back to the users after about that amount of hours. So it's more like an economy issue, not a capability issue in this case. Yeah, so with all this explanation, I hope in general, on the high level for the zk-Rollup, you understand, even though it's quite costly for the proof generation, but in theory, they are able to validate the state instantaneously, so that you don't need to wait for about 1 or 2 weeks time for like what the fraud proof for the Optimistic Rollup has happening, right? And in this case, you don't need a third party validator at all. It's generated from the layer 2. And the data availability issue, again, is bypassed to Ethereum, but later on talk about some other edge case for that. And you don't need a third party to monitor the state at all. And I already mentioned that the finality is about 10 minutes in theory, but in reality, it's much longer than that from an economy perspective. The bad part is the EVM compatible is really tough to implement. That's why for a company like Stockware, they choose to use a different programming language for their layer 2. So later on, we will talk about why. And also because of the limitation for the zk zero-knowledge proof. For example, for zk-SNARK-based zk-Rollup, the up limit, if you are not doing any client optimization, is only about 300 transactions per second. That's it. And also, it's a bit harder to implement other cryptography at all due to everything is bundled with zero-knowledge proof. So to dive a little bit deeper, just now it was more like a high-level description for the workflow. To dive a little bit deeper, by right, I will talk about Optimistic Rollup in more detail. But luckily, we have a guest lecturer to talk about Base, so I won't go into any of this. So next lecture, Yuan will come and talk to you guys how Optimistic Rollup in real production, how it works. But Arbitrum optimism is fraud-proof. The data is on-chain, which means all the transaction data will send to layer 1 as a call data. So that's why we call it a data on-chain. Differently for the data off-chain, where if you still remember the Plasma, the data actually stored on the layer 2. Plasma has to figure out a way to have the data availability there, but kind of fail. But that is called data off-chain because the data is not passed to layer 1. For zk-Rollup, also actually there are, even though in general the current zk-Rollup, the data is actually stored on layer 1 for all the major rollups. But actually before that, there's Validium or StackEx, which sometimes people also call it the zk Plasma. They actually store the data off-chain. We'll also talk about how this was done later on. So that's in general how you can actually differentiate this. And one thing I want to highlight here is, even though they use zero knowledge proof to do all the proof generation and verification, now people tend to call this method as a validity proof, not a zk proof, because as a user who never heard about this term, is very confused. Validity proof, the industry feel like it maybe is relatively easier for users to recognize. That's why you may hear the term like a validity proof, but this is actually a zk proof or zk-Rollup. So these are some of the categories for the commit chain for the rollups. So again, right, for the high level, the Optimistic Rollup for doing the dispute during the dispute period, and the zk proof for generating the proof and verify proof instantaneously, so that you don't have a window for any dispute happening in that window, because the proof is able to be verified instantaneously, right? To give you a little bit more details on how zk proof was initially invented and how they actually gradually put that invention from a scientist to a real production product. I think Stackware is a very interesting company to study, and because I was lucky enough to work with them actually for some of the projects. I know them much better than zkSync. I know Screw pretty well. My head of engineering is actually the founding engineer for Screw. But I think Stackware has a different method. That's why, in general, you don't find so much things about talking about Stackware. That's why today I want to use Stackware as a case study. But later on, I will give you a comparison between this method to other zk-Rollups. Again, right, I don't go into the detail for the Optimistic Rollup because Yu-Yang will talk about next lecture. So the scalable proof, the zk proof, are based on a very basic idea. About 70 years ago, I think it's longer than that, people realize whenever you are doing a polling for an election, the margin of error, for example, like last week there's a polling for Singapore. So before they announce the final result, they announce a sampling result, right? For example, the PEP win 56 by doing the sampling. And after they reveal the final count, the margin of the error is about, for my for the places I was in, is about 56.2. The marginal error is only about 0.2%. Why, all this, they actually use that as an indication for the polling is really because the margin of the error, that 0.2% compared to the polling result, sampling result and the final count, is really because that margin of the error, 0.2%, is independent of the population size, which is the whole population who are doing the vote. And it's actually dependent on the sample size. So in Singapore election, they use 100 ticket votes as a sample size. So if they increase this to, for example, 1,000 or 10,000, the margin of error will be smaller. So that's the facts, or has been proved in theory as a mathematics basic foundation. And so the cryptography scientists find out can't I use that method to do the validation of the computation integrity. And this actually theory was set up by PCP. This paper, if you are interested, you can read about it, about 30 or 40 plus years ago. It's called probability checkable proof. And this paper found out, yes, the same thing happening, which means I can only sample a small portion for the whole big systems and prove the computation integrity is valid by just sampling a very small amount of the whole computation. So the question here is, what is the integrity of computation? For example, whenever a banking doing a batching of your transactions every day, in general, large banks will do that batching during night, every day. Whether the system actually calculating the balance of all the banking accounts correctly or not, it's a ton of work. But by having this theory, I just need to apply a method so that I can only sample a smaller portion. For example, randomly I pick 100 accounts and check the history of the transaction of that accounts, and I'm able to validate the batching transaction is actually valid. So by doing that, the banking system do not need to check all the bank account. So that's correctness of the computation of the account balance is kind of called integrity of the computation, which means no one is doing something wrongly, badly, or maliciously. Right? So that's validating the integrity of computation, which means no matter how the system database, how big they are, as long as the sample size is correct, the margin of the error is fixed and acceptable. So moving further, they start to asking these questions, right? In the early part of the computer science history, for this kind of PCP, probability checkable proof, is it possible to use a very reliable a single PC to monitor a big group of supercomputers, so that they are able to make sure all the operations for all these supercomputers actually behave reliably, and even the hardware is not tested, but still they are able to monitor whether all these transactions or computations are correct or not. So this was an initial question for all the scalable proof. And 2 years later, they found out they can do that, but the assumption of a single PC at that time, in the early stage, is impossible to do that because the proof is very complicated to generate at that time. In 2005, another paper came out, and basically they are able to scale the systems. But the thing is, like, the PC was still not powerful enough to write a proof. But at that time, right, they are able to use a small computer to do all this verification already. But the only issue is the proof generation is taking too long. Just now I mentioned it's 10 minutes for now, but at that time it's much, much longer than that due to the chipset was not powerful enough at that time. But even at that time, right, as a banking system, you're actually able to do that to check the bank account balance, whether it's correct or not. But no one did that. No bank can actually do that, even though there's in theory it's working, and they're also using the sample code to actually test whatever mentioned in the paper. You are able to use the proof generated from all the transactions compared to the balance from the last day. You are able to verify this proof is correct. But somehow no one did it. Another reason is, at that time at least, majority of the people believe the banking is behaving, and there shouldn't be any malicious behaviors within a bank. That's why they didn't really implement that, but in reality, actually, they can do that. And moving further into 2018, it's a breakthrough where even a laptop can generate a proof, which means all the research has solved all the bottleneck of a scalable proof issue. Like, from every part of the procedures on proof generation, on proof verification, and using a small computers to do all these steps are there already back in 2018. But no bank still using that for transactions, and interestingly, the founder, which is Eli of Stackware, was only doing a research, and there's no implementation at all. No one wanted to do it. But I think he was on a conference, and the conference happens to be a blockchain conference. A lot of engineers from blockchain industry went to him after his talk about scalable proof. And those people tell them, like, oh, Eli, it seems very interesting theory, and this theory may be working for blockchain. And that's where he started this company called Stackware. And he established, after doing due diligence for the issues for scaling blockchains, like what we just discussed, but at that time no one teaching him, right? He found out, actually by applying the scalable proof to blockchain, which now we call it zk proof, they are able to do whatever we just talked about, verifying the proof generated from the computations. And these are all the things they invented. The two co-founders are all scientists from mathematics. And till now, I think this is a past data. Has been launching the main production already for standard, what we just showed you. But underneath, right, how that Stark works. Stark is the zero-knowledge proof Stackware is using. The full term is called, can't remember. The full term is called this scalable, transparent argument of knowledge called STARK. And whenever we just talk about the proof generation and the new state of the proof, this is actually the statement being executed on layer 2 for the proof generation and proof verification. The claim is starting state of the account, for example here, whose hash is X, the state root is X. Someone processed this amount of payments, this many payments or transactions by using a smart contract called program P. And the hash of the new system state is Y. And the proof system, the Starkware is doing is making sure all the transactions on layer 2 for this claim is, no matter what kind of transaction happening on layer 2, this claim is always correct. If the smart contract on layer 1 verify the proof or this claim is wrong by doing the proof verification, this transaction at the new block will be revoked. But underneath, right, the proof is proving this claim. That's what the proof system has been doing all the time. But definitely think about more generalized terms. The smart contract, multiple smart contract on layer 2 is not only one smart contract doing all these transactions. There are multiple smart contracts. But that's in theory underneath how the claim declared. And how the PCP initially was designed it's like a pseudocode-like set of constraints. Think about these pseudocode-like constraints. And the constraints is implied by the statement proved by X, Y, P, and transactions, which means is this claim. And by summating the solutions of the constraints, the verifier, remember the smart contract on the layer 1 is able to verify. And when they verify, right, it's not like verify all the statements, all the constraints. They only sample part of the pseudocode. For example, this part, I sample this part, maybe another part. And I check whether the constraint is fulfilled or not. If it is, the PCP basically declares the verifier is able to verify the proof generated here is actually a valid proof, which means the claims here, where the proof is based on, is valid claims. So that's how the initial PCP was implemented. If you still remember what Prof. Guo was mentioning about zero knowledge proof, the proof is always generated from cryptographic based on a certain statement. And this is the statement for zk-Rollup is doing. But Starkware actually, in order to making sure, because when you sample once, there's still a chance of like you are not able to sample the malicious behaviors. So what Starkware like extend the PCP was, they are using multiple pseudocode-like set of constraints, which means multiple PCPs, and the procedure are the same. You do the prover and you verify by sampling some of the data. But whenever you sample, right, you sample one fuse here and sample another one there. It's a layer by layer you sampled. So that means if you have 2 times 2, 2 times 10 kind of pseudocode-like constraints, you have to sample each layer on that. But when you do that, 10 layers for that. But when you do that, right, the margin of error is very minimum, which means whenever the verifier is able to verify this proof is valid, the new state and the new claims are all correct. But if the verifier sample and there are some errors happening, which if there's error, the probability to find that error is almost 100% in theory. And then the new state, the new claims are not correct, so that the new state won't happen at all. And the magic behind of this approach is there are two parts. One is the completeness for the proof systems, as mentioned by Prof. Guo. The first one, these two parts, the verifiers are behaving, right? They are able to sample and only sample some of the data, not all the data. And also, whatever the completeness happening, it's a soundness, which means the proof or the true statements satisfy all the constraints, like what we just mentioned. So by doing that, right, the stock system make proof whatever declared in the paper actually is working in real life. And another great part of the stock prover systems is the proof generation time scales when this proof size, for example, amount of transactions in one block increase is scaled almost linearly. So like T polynomial log Tx, this chart, this line here. And the verification time scale too, and even better on the green line here, it's a polynomial time for log Tx, which means the more transaction you have, actually it's relatively less time spent on per transaction basis for verification. So that's what all the research paper has trying to do on what we just described on different developments for the paper, so that now a small computer can generate the proof for a large proof system, and they are able to verify very efficiently on Ethereum. All the Ethereum for the full node is pretty, the requirement for the full node is very minimum. Even a laptop can write. Another great part of the Stark proof system is for the Stark, you don't need to do a setup. So whenever they burn up the layer 2 systems, the whole thing is there. There's no one need to set up a private key for layer 2 so that the system can kick off. No such procedure at all. And also there's no private key owned by anyone who actually can decide to shut down the system or not. So by right, the proof system, once it's on, the system is able to make sure the transaction happening on layer 2 are all valid. And from there, right, it's kind of a decentralized approach for zk layer 2. So for this, right, I won't go into the detail at all, but if you guys are interested about the Stark systems, they basically spend a lot of time to improve their mass underneath to make sure it's scalable. And they have a different Oracle protocol proof, interactive Oracle proof to be the new model of the proof system generation to make the proof scalable. And they also use this, the FRI to make sure the proof time is linear and the verification time is log in, and also the system is soundness and completeness based on this proof generation and proof verification. So that's what all the heavy loaded work has been in place. So now, when we look at, after I describe how the zk-Rollup, hopefully you understand. If not, you can ask me questions. Then let's review the fraud proof, right? The optimistic rollup. So the issue for the optimistic rollup is you have to believe in the validators or someone from the protocol, Optimism or Arbitrum, they are behaving, they are really checking the states. No one actually is doing something wrong, or no one is not validating the state. This is not, if you still remember the trilemma, any scaling trying to focus, this is definitely not a decentralized approach, right? It's a quite centralized approach. But they are able to scale. As for whether they reserve the security from Ethereum or not, it depends on whether they have, those fraud proof in place or not. If not, it's not secure either. But at least they're able to scale for the systems. So that's the optimistic route. On the other hand, whatever we just mentioned on the zero knowledge proof for Stark, actually initially they use it for Zcash. Anyone of you heard about the Zcash? Great. Yeah, so the Zcash is pretty much anyone using the Zcash network or the token there, you don't know who they are. Everything is protected. Everything is, all the accounts they're using zero knowledge proof to actually hide all the private information already, so that anyone can withdraw the money safely with their proof generation and proof verification systems. Even nowadays, the Zcash is still there. If you are trying to find a more privacy-driven payment systems, Zcash is still one of the choice. Because other than Bitcoin, right, everyone know your wallet address. Once, for example, CZ start to transfer some of the BTCs from his wallet, we are actually able to observe that. But if CZ using Zcash, no one can do that, can observe that. Everything is protected. There's no explorer can find this kind of address on those kind of transactions because everything is protected by zero knowledge proof. The whole idea initially was used for that, but the Zcash, I think, if I remember correctly, when Eli was there as their chief scientist at the Zcash, a lot of malicious behavior parties using Zcash to do different transactions, causing a lot of regulation issues. And so another different case is like once you use zero knowledge proof for privacy for this kind of use case, then the malicious behavior or the malicious party will come in and do some illegal transactions. If you use the same validated proof for privacy, for example, nowadays when we log into the computer or log into social logins, the company, for example, Meta or Google actually know who you are, right? But if you use the zero knowledge proof, validated proof to do the login, actually the company won't know who you are at all due to how the zero knowledge proof has been in place and work. But why they are not using that? But why nowadays, since it's so good, why nowadays no one actually using that to do your login at the current systems? Eli was telling me it's really because no one wants to pay for that because it's costly for the zero knowledge proof. And what's the point for a company like a Google to do that for user, but user doesn't want to pay, and it's a pure cost for Google. That's at least the answer from the beginning. But things has been changing, actually. If you search about Google zero knowledge proof login, it's there already. I think Google has have enough lawsuit about privacy issue. Finally, they want to pay for saving that lawsuit cost. But in reality, for big companies, it's only Google right now to do that. But for a company like Stockware as a startup, we can't afford to use the privacy for asking other companies to pay for the privacy solution with zkRollup proof. And what they end up doing is they provide this zk-Rollup proof for scaling layer 1. And based on what I mentioned on the computation integrity for the proof systems, so basically this system is self-sufficient. No one need to interrupt anything. The whole system will behave due to how the workflow has been there and how it's being set up. So now my question to you is, I'll later on tell you another story of why they do that. But from a blockchain perspective, why do they want to do that? From the trilemma perspective. And the question actually comes back to the old question is like, you guys studying blockchain for at least 6 months already. Why Bitcoin was almost 100,000 US dollars already? Why? Tell me why. Why? Anyone want to try? Anyone found a theory behind, like why I should buy Bitcoin now? I think it comes. That's only my set of answers to this question. It's not applied to everyone. Everyone has your own judgment about Bitcoin or this kind of system set up for computation integrity. It's because once the system is set up, no one can shut it down. What does that mean? No one can shut it down. What does that mean? I mean, to the extreme case, right? If the guys from North Korea decided to transfer 100 BTCs to another guy, and the US government cannot shut it down. That's an extreme case. But to a normal case, right? If I tell you another story I hear from an investor, is quite inspiring. So this lady was born in China. His daughter of a very rich family in China. His family ran the largest supermarket in Guangzhou or Fujian province. And about 30 plus years old, she was detected as a heart issue. And at that time in China, no one can really cure that. They have to went to the U.S. Harvard Medical School, working with the hospital from California. These two institutes had to work together to fix her heart issue. And the cost is about 20 million US dollars to do that operation and surgery. And all his family money are in China. And by the regulation of China, you can't move that money out with a short period of time because her life was in danger. And the only way she found out to move the money is to buy a Bitcoin miners, multiple miners in China. And by doing that, they are able to quickly, they find another way. It's not like mining immediately, right? they are able to quickly actually getting the money injected to the US account to pay the miners, because the miners were generating the BTCs for them. And by doing that, right, they are able to move with the immediate purchase of the BTCs and the miners of the BTCs. They are able to send the money for the surgery and operations. And the good part is that her life was saved after the surgery. And the lucky part was, because he bought so many miners at that time, even though now it's illegal, she became BTC rich at that time. And she actually was a guy helping her to manipulate all these issues, set up a venture capital to invest startups with all the BTCs she earned from the BTC miners. So what I'm trying to tell you here is not like it's anti-government. It's not. Just because there's a regulation, they need to find a way. And because the government cannot do anything with all this, at least they can move the money to different places. And there's always a case like that. As a nature of human being, you can't really avoid that. That's why the decentralized system is there. It will ever be there. No one can stop it. And when you're trying to set up a scaling solution, you want to duplicate that decentralization to the scaling systems, because whoever able to do this will be, who knows, right, next BTC. So that's, to my understanding, after working in the industry for so long, understanding about the valuation of Bitcoin, the valuation of the systems has their self-sufficient computation integrity. And these are all extreme cases, but you will never know what will happen with, who knows, right? What disaster will happen. But these systems will always be there as long as there's a computer turned on, as long as the computer who is on actually running the scripts. So that's the beauty of blockchain. Finally, there are some, good use cases, right? Okay, so wasting a lot of time talking about nonsense. I can just deem that as a story. And if any of you want to know the name behind the venture capital, I can tell you later on privately, not in a recorded session. So the first product from a system design perspective, the Eli and his co-founder, I forgot his name, he retired already. In order to prove the PCP or stack is able to work, or for any systems, when you want to put into a production, you do not start from the complex assumptions. You should always start from the simple assumptions, as simple as possible, to prove at least it's working prototype. And that's where they started with a solution called StackEx. People call it Validium 2, this kind of same thing, or zk Plasma, it's the same thing. What this system assume is now, because I need to use the proof to generate the proof and using the verifier on the layer 1 to verify the proof, I want to make sure the transactions on layer 2 is as simple as possible. Because if smart contract running any logic is too complicated for system to be able to really work properly. So that's where they started a simple assumption like my layer 2 for the StackEx only working for NFT transactions. I can mint the NFT, I can transfer the NFT, but if I want to do, and also initially it only support ERC 721, the most simple NFTs. They even cannot support other type of NFT at all. So they start from there, and they prove the whole thing really working. And these are the companies who used that before. We also integrate that solution to our own product before. And about, I think back in 2022, they are able to do this amount of tradings for the NFT. Another set of StarkEX support the token trading too. That's where the DYDX was using the StarkEX for the perpetual trading too, because they also support ERC20 trading as another set of verification for StarkEX prototype. And so they are able to mint this amount of NFTs and handle this amount of transactions back in 2022. And the cost is decent, cheap. And the whole thing was really scalable and approved back in early 2022. And you see this, the green line here. That's actually transaction happening on that day. It's about 4 million transactions happening on that day. Anyone guess what happened during that day? Early 2022. What happened for crypto? Any idea what happened in 2022 is a disaster year for crypto. A lot of issues happened. No one guess? Yeah, it's Luna. Luna crash. Luna crash, and people are, Luna crashed, then FTX shut down, right? Due to Luna's crash. Actually, this event happened because a lot of people start to worry about my assets in centralized exchange due to the Luna and also FTX. And people start to transfer the money to DYDX during that day. But after that day, people are relaxed. Then they transfer back to their assets. But that's what happened. But at least during that day, right, it kind of verify, the system really able to scale. And there's no issue at all for deposit and withdrawal. It's kind of interesting how the developed the theory, implement that with 100+ engineers, and verify the first version of the zk-Rollup actually works. So now it's the time for the protocol to actually move on to general computation. Because he was using the NFT and token for verifying the whole concept was working. And in order to support a generalized smart contract, that's where the Starnet was started. And the idea is very similar. The difference is all the smart contract running on the layer 2 is supported for any computation. It's a it's a NP complete for the programming language. It's like similar to Solidity, where you can run any computation on the layer 2. This is the workflow. I won't go through into the details. But at the end of the day, all these transactions, remember the claim we mentioned about the zk proof. They run multiple programs, have multiple transactions, and they send to the prover, and the prover is the plus to generate the proof. Because now the computation is much, much more complex than just NFT and token. That's where prover here is their bottleneck right now, still. That's where they take about 12 hours to finalize the prover because they have to wait for more transactions coming in to make it more economy sense for the proof systems. But the verify is instantaneously. after they receive the prover's proof. And there are normally two states on layer 2. One is accepted on layer 2. This is not a finality yet. Only program accept on layer 1. That's a final confirmation for the transaction, like what we just did for the visual. Right now we talk about computation integrity. Look at this system. Do you think this is a decentralized system, fully decentralized system? Right or wrong? There are actually some places due to the bottleneck of, for example, the prover. Right now, the prover is on the central server. It's actually on the most expensive AWS node for the prover. These are still centralized. And their plan is to decentralize this prover. And another place is centralized is the sequencer. The sequencer are the places to aggregate all the transactions from different smart contracts, from different accounts. These sequencer are the places to sequentialize all the transactions into the queue. Why the sequencer need to be decentralized, but now it's actually centralized, is because think about a DEX. For example, this user from this gateway trying to buy ETH at, for example, 1,800, and there's another transaction happening immediately after, which is a cheaper price. If someone control the sequencer, which is possible due to it's centralized, they are actually able to fulfill the cheaper price first, become higher priority, queued in advance. And these become an issue for transaction sequencing, which become not fair to the people submitting a higher trading fee for the ETH. And that's actually an MEV issue, if you ever heard about MEV for DEX, which is normally caused by this kind of unfair sequencing. That's why this place is not decentralized yet. And all these flow are decentralized. So that's why the current work of Starknet is decentralize this place and decentralize this place. Because the prover itself is kind of computation integrity, even though it's a centralized server, right now, by default, Starkware is not doing any decentralization yet, but they will definitely have a plan to do this in future. Because if you guys are still remember, what's the underlying instruction set for Solidity? It's opcode, right? Opcode, OP code. It's like assembly language, right? For Starkware, they are using different set of instructions because if you heard about a term called circuit, so basically they are writing a circuit for all the zk proof. And the language they are using called Carol, because underlying the Stark, they are using a lot of hash, mod operations, much more than the Snark, where they have a lot of algebra, polynomial operations. That's why Stark is more efficient. But because of that, the system is designed differently, and they had no choice in order to make sure, if you write a assembly language for the CPU and GPU is different, right? GPU is using CUDA. In order to really make it more efficient, they had to choose a different language other than Solidity, just no choice due to how they design the systems. And as I mentioned, right, the Stark has all these kind of operations. That's why Carol is much better than the Solidity. But nowadays, because Carol was initially designed like a Python, it's so difficult to code. And Solana become more and more popular. More Rust engineer was joining to work on the smart contract. That's where now it's quite similar to Rust language right now, which is easier right now for the developers to adopt, but still, compared to Solidity, it's not that popular yet. That's part of the hurdle why their ecosystem is not active, but doesn't mean their technology is not good. And when you talk about zk, we talk about StarkNet due to the Carol. It's actually assembly on the bytecode level, not opcode. And at the language level, they are using their Rust kind of Carol language. We have a wrapper on top. The community used to work for, but it's not that popular anymore due to it's not fully compatible even with the wrapper. So that's why we call it the zkVM. And actually there are few more zkVM right now. And the recent research from Vitalik actually also support this may be a better path for scaling zk-Rollups. And that's where he has been thinking about using the RISC-0, which is another kind of zk-Rollup implementation to replace to enhance the current EVM. When you talk about doing the verification on layer 1. But anyway, so for zk-Sync, they make it more compatible, where they are using, even though they are using Zinc instruction, but on top, it's actually quite similar to Solidity. Only few instructions are not there yet. But right now, I think they fixed some of the issue already. It's kind of compatible, but not 100% compatible yet. So I put a radio here because we are also using zk-Rollup underlying. And, but differently is we trying to use the hardware to accelerate. That's where we are using actually CUDA instruction underneath. But on top, we compile from opcode to CUDA instruction. When you compile the source code, solid source code from here, we interpret to CUDA instruction. That's a way of workaround for the compatibility of Solidity. Similarly, Scroll using a similar approach, but they are not optimized or doing the hardware acceleration at all for the opcode. But their EVM running on top of zk EVM or layer 2 is actually the modified directly from GETH, the gas. Hence, they make sure all the interfaces are compatible with Solidity, and that's why they are pretty compatible nowadays. Yeah, this is Ethereum. For all these, right, these currently only Starkware, Polygon, zk EVM are using Stark. Polygon EVM are using Stark plus Snark. Later on, I'll tell you why. All these other companies are using Snark. What's the difference? We already talked about the Stark in more details, but for Snark, on a high level, when you compare, the verification is actually linear increase, a little bit worse than the log-n verification complexity. And the proof size for Stark is actually much bigger than Snark. The proving time for the Stark is actually shorter due to their efficiency of the calculation of the proof and the verification, and also the enhancement of the scaling. But the big issue for Snark is not this the big issue for Snark is the setup, trusted setup, where when you initially set up the Snark, there are one party or multiple party has to be involved to set up the private key in order for the proof start to generate the proof. Approver start to generate the proof. That's where we have a trusted setup procedure, which is too centralized. That's a big issue here. There are multiple ways to work around. For example, using multi-sig signature called MPC to work around this issue, to kind of more decentralized, but still this bottleneck. And you heard about quantum resistance from Prof. Guo. From the algorithm perspective, because how they are doing underlining for the mathematics, for Stark it's a quantum resistance, for Snark it's not. So which means once the quantum computation really becomes stable, then Snark and Bitcoin are all now safe. So in order to work around this issue, which the only issue right now, if we talk about the difference for Stark, is actually the proof size. That's why Stark has to wait about 12 hours to get the proofs to be generated from the cost perspective, because the proof size is just too big and it's not efficient. The way to work around is whenever I generate a big proof size, I want to contain as many proofs as possible. Ideally, they can run multiple proofs for multiple zk-Rollups, because all these companies support multiple layer 2 or layer 3 as an app chain. Later on we talk about it. What's that? So if you aggregate enough transactions into one proof, then the proof size won't be a big issue anymore. If there are parallel proving systems there and multiple transactions happening, so that you can really contain more transactions in one proof. So that's the approach for Stark. And the other approach is, since Snark has a smaller proof size, why can't I, all these I can use in the Stark to generate the proof, but when I generate the last proof, I can use Snark to shrink the proof size. So that's actually the approach Polygon taken for their newly launched zk EVM launched last year. But it takes a lot of effort to get it done. So that's one of the ways to solve the issue of Stark. Yep. And because of the different compatibility to the different, for the layer 2s, for the different EVM compatibility, there are different types. The type 1 has no change at all. This is, I don't think anyone ever done this for the EVM, like no change and you move on layer 2 and it's working. No one make it work yet, because underlying, as we're showing here, you have to always modify the zk EVM to make sure once you compile to, once you have an opcode, you are able to write all this logic on the circuit. The circuit itself is if you want to dive deep, I think you guys learned about zk Snark from Justin before, right? He already talked about, I hope you all still remember that, how you write a Snark circuit. And underlying for the EVM, we also have to change that to write that circuit in order to generate the proof. That's why, in general, the EVM has to be modified. Right? It can't just work. But the Optimistic Rollup can just use the EVM without any change. That's how initially the Optimism and Arbitrum has been doing. But I'm talking here about zk EVM. Right? And the tab 2 is only change the data structure for the storage. Again, no one is doing that yet. But majority of the zk-EVM is actually, you have to change the storage, the hash, and also pre-compose. These hashes are for the snark and stark. These pre-compose, again, is for the circuit. So these are the companies making it type 3, which is already pretty good from a compatibility issue for the projects deploy the smart contract. And then the type 4 is not compatible at all to the EVM. That's how they differentiate based on the EVM compatibility. And overall, when you compare the Optimistic Rollup and the zk-Rollup, these are the difference. I won't repeat again because we already talked about it, some of them. And also, this is another more comprehensive reference for you guys if you want to choose a layer 2 solution for your project or for the companies or the company's project later on you're going to work on. For the project itself, I hope you guys can not just to focus on the project itself, but think about the project I mentioned is more like the projects you guys are working on right now for the group by group projects. I hope you guys apply those demo or applications toward the scaling solutions. At least you have a thought process, writing in the reports or in the video recording or the PowerPoints when you do the recording, telling me or Prof. Guo like why you are choosing that blockchain to deploy your projects to. You can use this chart as a reference, like why you decided to choose, for example, Validiums to scale, because maybe, for example, I'm expecting just now there's a student asking like they want to do AI agent projects. Maybe you choose Validium because you are expecting the throughput for AI agent for your use case will be at this level, like Visa master level. That's why you decided to choose Validiums. Yeah. So I hope you guys can really go through and down the project from this perspective. But again, right, this is a very comprehensive comparison. Hopefully it's useful for you for the project and also for future. But I won't go through in details at all. And these are more references if you want to know more about implementations. For example, OVM is pretty popular nowadays due to they have this OP stack. You feel free to read about how they get it done and what's the difference between OVM and EVM. Even though it's EVM compatible, due to their optimization, they actually change to their own version of the EVM. Even it's an Optimistic Rollup. Feel free to read about it if you're interested. So finally, we talked about this CryptoKitty architecture before, where in general it's a front end and the smart contract running on Ethereum. Again, right, this is a scaling issue. I think I was mentioning this a bit already. There's a DeFi summer, there's an NFT summer, and all these causing the scalability of the blockchain. And with, for example, Uniswap initially only deployed to Ethereum, and now due to the transaction happening more often on Uniswap, we have to choose a more scaling solution like Optimism and Arbitrum. And because more companies decided to do more different, there are token pairs available, for example, only on Starkware, and they also have to support a bridge when they do swapping. That making the system more difficult. Even though they solve some of the scaling issues with these layer 2s, but now they have new challenges now. Like how are they able to swap from Ethereum to another, like a non-supported blockchain on their own scaling. But at least right now they are enhancing and adding more scaling solutions to their Uniswap itself, and this become the new architecture for companies like Uniswap. And now it kind of solved the scalability issues compared to the initial setup, which is only Ethereum. So the reason I want to talk about the gaming last year and also this year is because I'm not sure how many of you heard about Step-In before. Step-In is a kind of game has been, again, quite popular last cycle. And so they were initially trying to do the Web 2.3 game, where the asset, they want to do asset on-chain and trading the asset on-chain too. But the game logic is still on the central service. That's where we call it, it's not a standard at all, but some people call it a Web 2.3, 2.5 game. And the Web 2 games, all the NFTs, basically the scanning the game skin are all on the central service, which is the Web 2 plus game. All the tradings are actually happening on-chain. Initially, Step-In actually chose to do this path, and that's why they decided to work on Solana, because they imagined their system was scale, and a lot of people will treat their shoes in their own Step-In apps. And they were estimating the throughput, when I talked to their founders, is actually a consumer level. And because the founder has this mobile internet experience, they know that when that happens, mass adoption for their games, the throughput is actually much more than 20,000 transactions per second, much more than the Visa and MasterCard throughput level. So at that time, they got no choice but choose Solana, because Solana declared they were the fastest blockchain at that time when Step-In started. But after they started to deploy the whole projects, they realized, yes, Solana can handle some of the, at a good time, Solana can really scale, but for some complex smart contract operations for their game logic, or game asset trading, Solana actually cannot handle the workload. Because whenever, as I mentioned, right, the throughput is only one parameter. It's not for all the transaction type. For example, when they mint the NFT, the Solana becomes much slower compared to only sending an NFT to another people or trading the NFT to another people. That's where Solana become a bottleneck when they scale their user base. And Step-In actually has to fall back to the Web 2 plus version of their gaming asset, which are the shoes. They just had no choice at the time. And so interestingly, even though in general the blockchain has been very slow, but there are companies started to work on fully blockchain game. Why? Why people want to do fully blockchain game? Which means not only the NFT and trading are happening on-chain like Web 2.5, even the game logic, for example, you hunt some beasts and you getting some tokens or NFTs after you hunting the beasts. The whole logic, like how many beasts you have to hunt, will be aggregated back to your own wallet assets. That logic is also happening on-chain. Imagine if all this gaming logic also happening on-chain, what kind of workload the blockchain has to really take in order to support more users to play on the blockchain. Imagine your Warcraft or Minecraft, whatever games you are playing, all the logic actually happening on blockchain. That's a different scale for the requirement of the blockchain scaling. But there are companies doing that. And when they do these kind of games, you can call it a fully on-chain game, or the industry is really good at naming the narratives. People also call it autonomous game because all the game logic are there. And the logic behind is actually simple. They are trying to solve some of the industry issues, which is we don't talk about too complicated games. We only talk about, for example, the poker game. If the poker game logic is on-chain, and you play the poker game for one poker game, blockchain game, if the company decided to shut down, if it's a centralized poker game, for example, the game provided by SEA from Singapore, then whatever you have done for that game is lost for your effort, for your contributions, right? What if all this logic can be kept? And because it's on blockchain, the user basically can just change the UI. For example, the user can just change the front end. All these smart contracts are still there. So even though C decided to close this game, the whole logic and the history of the play are still on the blockchain. And the user actually another company can pretty much just deploy a new set of UI, and the whole thing will be kept as an asset to the users so that the experience won't be lost. So that's why people are working on this blockchain, fully on-chain games. And one of the big issues for that is scalability. It's much, much more heavy loaded compared to even just step in. Then how you do that? So the idea was started doing that. Optimism is doing that. Which is now I'm doing a single tenant. So maybe I deployed my first game on a generic layer 2. Once the game becomes more popular, I can move the dApps and the logic to their own app chain. You think about the Cosmos. The Cosmos is to deploy a layer 1 with a very difficult bridging issues to be resolved. But this layer 2 app chain concept is actually rely on the layer 2. And we deploy the app chain on layer 2 so that you have a single tenant scalability for this app chain. And some people call it the layer 3. But doing this approach, right, you are able to bring all the stack to the users. And for example, think about this as step-in. For example, if step-in deploy their first version of the games on StarNet, if they do that, if their capacity become much more transaction per second, and then they actually can deploy another StarNet to their own games so that all the game logic can move immediately to the app chain. And now if the bottleneck for StarNet is about, for example, right now I think it's about 1,000 transactions per second. And if they share this, right, it's pretty much I have to share the throughput with other blockchains, with other apps. And now if I redeploy another StarNet on layer 3, I own the 1,000 transactions per second for myself. If the StarNet is able to enhance the performance further, then the step-in for this app chain can enhance the performance further. So that's the idea of supporting this kind of gaming, fully on-chain games. Similarly, that's why when you hear this term, Optimism have their own option, but because how the Optimism has done the the scaling for the fraud proof, they have no choice but have to deploy multiple layer 2s. For the next lecture, I think the last lecture, we'll talk about the use case, how a company like Workon is doing with Optimism. Basically, they deploy another layer 2 because this really hit the bottleneck of Optimism. And they have to spin off and doing their own app chain. Similarly, zkSync also have their own kind of hyperchain structure to support multiple companies to launch their own layer 2 or layer 3. It's all open source. They can easily deploy their own app chain with the open source stack. And in the past, if you are deploying, if a bank wants a privacy-based blockchain, for example, if OCBC want to deploy a blockchain, but they are worried about the user's privacy, they have the past choice is only to deploy a Hyperledger-based or a private blockchain so that they are able to hide certain informations whenever you record the data on ledger. In the past, they have to do that. But with all these fractal scaling solution, they are actually able to hide the privacy on layer 4 or layer 3. And what does that mean is they can use the zk proof to hide the privacy for those data, where, for example, the bank doesn't want to share your account balance. So that's where you are able to actually deploy a privacy-based app chain on layer 3 or layer 4. And that's how it kind of stacked on top and become layer 2 or layer 3 and layer 4. Basically, this is another direction the industry is moving in order to scale the blockchain further beyond just the layer 2. Yeah, so that's pretty much all I want to talk about today for zk-Rollup.